Investigate and explain that when a force is applied to an object but it does not move, it is because another opposing force is being applied by something in the environment so that the forces are balanced. Identify when forces are balanced or unbalanced. We can measure force using a tool called a spring scale. You might be familiar with this if you go fishing. You use it to hang your fish on the hook, and then that will tell you how much the fish weighs. On this side, you'll see that it measures grams, so I can take the hook of the spring scale, hook it onto the Jeep, and then by hanging the Jeep from the hook, I can find the mass of the Jeep. The spring scale is not terribly precise. It's not super accurate. This measures a mass of about 120 grams. You'll see the Jeep hanging from the hook there. So about 120 grams. And if I turn the spring scale around to the other side, you'll see the unit of measure. There's grams on this side. If I flip it around, here's the unit of measure for force, N, which stands for newtons. We measure force in units of newtons. If I hang the Jeep from the spring scale, just holding it, you'll see that the force required to hold that is about 1.3 newtons. 1.3 newtons just hanging the Jeep there. And you'll see the measurements 1, 2, 3, 4, 5 as we go along. So this tool, a spring scale, is used to measure force in units of newtons. Now, what I wanted to do was to pull the Jeep and measure the amount of force needed to pull the Jeep in units of newtons, but I found out when I pulled the Jeep that because the wheels made it so easy to roll, the spring scale wasn't actually measuring anything. It didn't measure any force needed to pull that Jeep. So I had to come up with another way to do that. Let's take a closer look at the scale. You'll see that when I start to pull, the spring doesn't even move, the Jeep moves, so it takes hardly any force to do that. So that wasn't going to work. I couldn't show you the amount of force, balanced force, required to pull the Jeep. So I had to come up with a new idea, some other way to show you that unit of balanced force, those balanced forces up until motion happened, because all this showed was unbalanced forces. So this demonstration didn't work. It's only showing unbalanced force, and sometimes that's the way science goes. So we go back to the drawing board and come up with a new idea. So I've got a paint opener here that I can take the largest steel sphere that I have and drag across the table. Put that steel sphere on there, and here we go. Now, when I start to pull the spring scale, 0.5 newton doesn't move. 1 newton, 1.5, 2 newtons, 3.5 newtons. The spring is stretching, but the sphere itself is not moving. Forces so far are balanced. There's no motion happening. So we have balanced force, and this is what I wanted to show you. 0.5 newton balanced, 1 newton balanced, 2.5, 2, 2.5, 3, 3.5, and now at 4 newtons, 4.5 newtons, there we go. Now the steel sphere starts to move. Now we have unbalanced force. How much force does it take to move that steel sphere? 4.5 newtons. Now, I wanted to find the mass of that, so I go back over to my digital scale, which is much more accurate than the spring scale, and I couldn't find the mass of this using a spring scale anyway. 2,325 grams. 2,325 grams. So now I can show balanced and unbalanced forces using the largest of my steel spheres by placing it on this sled and measuring the amount of force needed to pull that steel sphere using a spring scale. No newtons, forces are balanced. 1 Newton, forces are balanced. All the way up, 2, 2.5. There's no motion. The sphere hasn't started moving yet. At about 4, 4.5 newtons, friction breaks. The sphere starts to move. I can pull it across the table with 4 newtons of force. That is an example of balanced and unbalanced forces. Motion has occurred.